In this video, we're going to be learning about nomenclature rules for aldehydes and ketones following IUPAC nomenclature rules. So there are some common names for aldehydes that are always used. So for instance, for formaldehyde, you'll see it has the word aldehyde in it, acetaldehyde, benzaldehyde, and so that's a benzene ring. That's a methyl group, that's a hydrogen. So you can see how these names were derived originally. So IUPAC will use this benzaldehyde root. That's acceptable for IUPAC, but we are going to be focusing on IUPAC nomenclature for these other aldehyde groups. So our IUPAC nomenclature for aldehydes is going to build upon our past nomenclature rules. We are still going to be finding the longest carbon chain. Now our longest carbon chain has to contain our aldehyde functional group. And so we have to contain our aldehyde functional group. So in this molecule, we have to include this carbon here. This carbon is going to be labeled carbon number 1 because it's going to be at one end. And so alright, aldehyde C is C1. So remember the aldehydes are always terminal, so since it has to be in your chain and it's always at the end, it's always going to be carbon number 1. Now we can move past that. This one must be number 2. That's a 3. That's a 4. And so there's 4 carbons in that chain, and so that is butane. The suffix for an aldehyde is not ane, it's anal, butanal. And so when you pronounce this, you have to enunciate butanal. I know it looks like anal, but please do not pronounce it as butanal. It's butanol. Butanal. Butanol is an alcohol. Butanal is an aldehyde. Gotta watch your pronunciation, folks. Butanal. Now, let's see. We got this methyl group here. Methyl, methyl. And so that's a 3-methyl. That's a 2-methyl. And so that's 2 methyl groups. And so that's going to be a 2,3 dimethyl. So both of those are substituents on the longest chain. If they were multiple substituents, we would apply our other nomenclature rules like alphabetizing and whatnot in order to minimize numbering in the direction that minimizes numbering, all that good stuff. Nomenclature rules for ketones. The suffix for a ketone is the -one, so you would remove the E and replace it with an -one. You do want to include the ketone in your longest chain. This is an example with a cyclic ketone, and so you can see this ketone is part of the ring. And so this is always treated as carbon number 1. It's a 6-membered ring. And so that is cyclohexanone. So enunciate it where you can read the different syllables. So cyclohexanone. All those different syllables there. If that's carbon number 1, we can number around the ring in the direction that minimizes the numbering of the other substituents. And so this is closest to that point, and so this is going to be number 2. No, that's number 2. That's a 3. That's a 3, and that's a 4. So it's a 3-ethyl and a 4-methyl. Ethyl is going to come first, alphabetical. And so we're going to put the 4-methyl on first. and then the 3-ethyl. So 3-ethyl 4-methyl cyclohexanone. And so you can see that the nomenclature rules just keep building upon what we've already learned. So here's some practice nomenclature for you. Go ahead and pause the video, identify the functional group, and name the following molecules. Unpause the video when you are ready to continue. Okay, so for our first molecule, this is an aldehyde. So this must make my carbon number 1, 2, 3, 4, 5. And so that is pentanal because of the aldehyde. And I have a chloro off of carbon number 4. And so that is 4-chloropentanal. For this one, you can see I have 1, 2, 3, 4, 5, 6, 7 carbons. If I count from this end, I have 1, 2, 3, 4. If I count from this end, I have 1, 2, 3, 4 to the ketone. So either way, that ketone's a carbon number 4, so I might as well number from this direction in order to minimize the number of this other substituent. So this one was going to be 4 no matter what, so I might as well minimize the numbering of this one. So that's going to be a 3-methyl group. 1, 2, 3, 4, 5, 6, 7. That's a ketone. So 7 carbons long is hept. All single bonds is an, and then one. Make sure you remember that you do have that an syllable in there. A lot of times in this part of the semester, people start leaving that out, but that indicates that you do have single bonds. And so we want to remember to keep that syllable in there. That does mean something. And then we have our 3-methyl group. So 3-methyl heptanone. That's not a space in there. I just didn't budget my space well. Here, I'll drag it out a bit more. 3-methyl heptanone, no space. Okay, so this is a 5-membered ring. So that's going to be cyclopentane. This carbon here represents a ketone. And so I'm going to erase the E and change that to one. That's a carbon number 1, 2, 3. So I have an ethyl group off of the 3rd carbon. So 3-ethyl cyclopentanone. That's all one word, but I didn't budget space well. I realized that up here I didn't put the number for the ketone, and I need to put the number. So that's 3-methyl 4-heptanone. Location of ketone. Here's another practice problem for you. In this case, we are trying to draw the structure given the name. Go ahead and pause the video and try to draw these structures on your own, and then unpause the video when you're ready to check your answers. Okay, let's go over this. So for our first one, we have 3 carbons, all single bonds, and an aldehyde functional group. And so 3 carbons long, 1, 2, 3. I have a aldehyde functional group on one end. So I got my aldehyde functional group. What else do we have? We have 2,3 dichloro. So this is number 1, this is number 2, and this is number 3. Make sure you draw the line out to the chlorine and don't just write your chlorine at that end, because then you'll end up deleting your carbon from your drawing, and you want to maintain having 3 carbons as you draw. Now for our next one, we have 4-methylpentanal. So that's 5 carbons long. 1, 2, 3, 4, 5. And then my aldehyde's always at one end. And so I did not draw that in the correct location because I just deleted my 5th carbon. 1, 2, 3, 4, 5. My carbonyl has to be at the 5th carbon, and then I can draw a line out to an H. I want to make sure I maintain 5 carbons. 1, 2, 3, 4, 5. And then this says 4-methyl. So if this is carbon number 1, that's a 2, that's a 3, this is a 4. And so I must have a methyl group there. I don't need to write methyl. I can just leave it as a stick coming out of the structure. I'm going to just draw that better. Okay. Now for our last one, we have butanone. So that's 4 carbons long. You can also do this in condensed structural format because it didn't specify what structure drawing to do. So that's 4 carbons long. We have a ketone at carbon number 2. So the location of this is carbon number 2. And we have a methyl group at carbon number 3. Now that I have my kind of skeletal outline a bit, I can fill in the missing hydrogens. This carbon needed 3 hydrogens. This carbon needs 0 hydrogens. This carbon needs only 1. And this carbon needs 3 more in order to have 4 total bonds. As we name more complex molecules, you might have noticed that there seem to be some rules that are conflicting. Like if we have both an alkene and an aldehyde, or an alcohol, whatever, we have to make our longest chain containing that functional group. So if we have multiple functional groups, how do we decide which functional group gets to be the suffix and which functional group gets to be in the prefix? And so we have a table of priorities for these functional groups, and we have our carbonyl functional groups are going to be higher priority. So carbonyl functional groups are highest priority, and then down at the bottom are alkanes, and then our halogens and ethers. Ethers and halogens never even have suffixes associated with them. Ethers and halogens are always in the prefix. So remember, the ethers are alkoxy, like methoxy, and so forth. If we have both an aldehyde and a ketone in the molecule, the aldehyde is going to get the suffix, and the ketone is going to become a substituent on that molecule. And so a ketone as a substituent, like a prefix, in the prefix you would see oxo. And so oxo means ketone, oxe means ether. Hydroxy means alcohol. So these are what it is as a substituent when it goes into the prefix. As we introduce other carbonyl functional groups, we'll introduce like carboxylic acids and amides, which rank higher in priority than aldehydes. And so eventually aldehydes can be in the prefix, but for now they are our highest priority functional group, but that will change as of next chapter. So here's some examples of that. You have been doing this already without really realizing it. This molecule has 1, 2, 3 carbons, so that's propane. This is the suffix. This is part of the prefix. And so this is propanol, and that is 2-chloro. This molecule has both an aldehyde and a ketone. The aldehyde becomes the suffix because it's higher priority, and then the ketone gets thrown into the prefix as a substituent. So if this is carbon number 1, this is carbon number 2, this is carbon number 3, that's carbon number 4. And so that's where this 3-oxo comes from. So this is 4 carbons long, butanal for aldehyde. 3-oxo means ketone at the 3rd carbon. For this molecule, we have 1, 2, 3, 4, 5 carbons long. So that's pentane. The ketone is going to be the suffix because it's higher priority than this alcohol. So that's going to be our suffix. Our ketone is at carbon number 2, so that's 2-pentanone. The alcohol is at carbon number 4, and so that is 4-hydroxy. And so the alcohol becomes hydroxy, and that gets to be the suffix. Here's some practice problems for you. Go ahead and pause the video and try to work out the names for these molecules. Unpause the video when you're ready to check your work. Okay, so this is an aldehyde. So we know that we're going to get the suffix al because aldehydes are higher priority than alcohols. And so this is going to be carbon number 1. That's 2, 3, 4, 5, and this is a methyl. This alcohol is off of the 3rd carbon, and so that's going to be named 3-hydroxy. And then that's 4-methyl. Hydroxy comes first in the alphabet, and so that's going to be 3-hydroxy. That does not look like a HY. 3-hydroxy, 4-methyl, 5 carbons long is pent. I don't need another dash, do I? Pentanal. This one has how many carbons? 1, 2, 3, 4, 5 carbons. And so that's going to be based on pentane. Now let's see, we got this one, which is an aldehyde. This one is a ketone. Aldehydes are going to be higher priority. They are at the end. And so this is going to be an al. This one has to be carbon number 1. Aldehydes are always terminal. That's a 2, 3, 4, 5. And so we have a ketone at carbon number 4, and so that's going to be 4-oxo. 4-oxo pentanal.